Welcome to Unit 1, Lesson 1, the unit circle, and this is where we're going to learn how we can find an exact value without using a calculator. So our end game is if I ask you what is the sine of pi over 6, you're going to be able to tell me what that ratio is without using any assistance from technology. So how do we begin our discussion? Well, let's take this triangle and we're going to place it on a unit circle so that we create an angle in standard position. So I've used the positive x-axis, this is my terminal side, and this makes my angle theta. If I drop an altitude, that's where I get my right triangle. As a reminder, remember that whatever measurement is for angle theta, it is corresponding or congruent to its arc that has been intercepted. So let's look at what it means to redefine the opposite, adjacent, and the hypotenuse. In my triangle, the x-axis part is going to be my adjacent side. The y-axis part, or the vertical, will be my opposite, and this is the hypotenuse. But now that we have looked at this from a coordinate perspective, what the adjacent side becomes is really your x value. The opposite side is your y value, and your hypotenuse is always going to be the radius of that unit circle. Even if I choose to draw my triangle in quadrant 2, this is going to be your reference angle. I realize that this is your angle in standard position, but when I drop that altitude, we will refer to angle theta. And again, your adjacent side is x, your opposite side is your y, your radius is still the hypotenuse. And that's going to be true even if I draw a triangle in any of those quadrants. So as a result, you'll need to rethink SOHCAHTOA, and you need to think of it in terms of x, y's, and r's. Your sine is y over r. Your cosine is x over r. Your tangent is y over, I have a mistake there. Let's erase that. Your TOA is y over x. Then you have your reciprocal functions, would just be the reciprocal of those. So what is a unit circle? A unit circle is a circle where we have purposely made the radius be 1 unit. So I'm sure you've done a lot of unit analysis, so we're talking about a unit circle. So on purpose, in the next picture, I have divided the unit circle up by marks of 15 degrees. What is this in radians? Well, we know that 15 degrees over radians, if I do this by proportion, would be equal to 180 degrees, right, over pi. So when we do some cross product work, I get 180 times radians equals 15 pi. Divide both sides by 180. And if you reduce 15 over 180, you get pi over 12. So 15-degree increment is equivalent to pi over 12. And you'll see I chose this because we know that we have angles in radian measure. For instance, pi over 6 is 30 degrees. Pi over 4 is 45 degrees. Pi over 3 is 60 degrees. And if you look at their denominators, their least common multiple is 12. So there should be a unit circle that you can have, that you can make a little bit bigger. I believe I made it a link in Schoology. And I am going to write all of this out because I'm teaching to you on a video. But I will tell you that when I get to problems, remember our end goal. Our end goal is to be able to evaluate the sine of pi over 6 without any type of assistance. I'm going to let you know I don't need every cotton pick and piece of information in front of me. But since this is the first time we're doing it, let's go through this by degree. So this is at 0 degrees, 15 degrees, 30, 45, 60, 75, 90. Keep adding increments of 15. So we're at 105, 120, 135, 150, 165, 180. Then I'm at 195. Then we're at 210, 225, 240, 255, 270. Keep going. 285, 300, 315, 330, 345. Now I will tell you in doing this, we don't have a special 1575 right triangle. So for today's lesson, we'll be able to do these actually when we get to Unit 2. But for now, we cannot find the exact values of the first and the last angle in each of these quadrants because we don't have a special 1575 degree ratio. All right, now let's talk about what these are in radians. This is why I have chosen to break this down into groups or into pi over 12 units. All you have to count is pi over 12. This is 1 pi over 12. This is 2 pi over 12. Does it reduce? Yes, but I just count 3 pi over 12, 4 pi over 12. Do they reduce? Yes. And if you want to write them in their reduced form, you're welcome to it. But all I have to do is just keep counting. Sorry, that should have been 5 pi over 12, 6 pi over 12, 7 pi over 12, 8 pi over 12, 9 pi. You get the drift. So again, this is what I mean by if you can count and you can think of the unit circle this way. But again, I want this to be visual. 12 pi over 12 is pi. That reduces. So we have 13. Oh, got a little bit ahead of myself here. 14. Again, that reduces. 15 pi over 12 reduces, 16 pi over 12 reduces, but notice like 17 pi over 12 reduces, so we can't find the exact value of that. It doesn't come from a special right triangle. And then we have 18 pi over 12, which does reduce to 3 pi over 2. 19 pi over 12, 20 pi over 12, 21 pi over 12, 22 pi over 12, and last we have 23 pi over 12. All right, so again, my goal is to find a question like the sine of pi over 6. The first thing you're going to have to do is you have to locate the angle. Well, if you don't know where pi over 6 is at, you can convert it to twelfths, and I just count 1, 2, and that's where I'm at. I'm at 30 degrees or pi over 6 radians. That is the purpose of why I have put this into twelfths, so that you're able to get to your radians fairly quickly. So this is the first step of being able to do a problem like the sine of pi over 6. You're going to have to locate the angle, and what I've just done for you is I've shown you in 1 unit circle where all your degrees and all your radian measurements are located. Let's move on to the next step. All right, we need to recall our special right triangles. So remember that in a 45, 45, 90 triangle, these are each one, and my hypotenuse is root 2. In a 30, 60, 90 triangle, so this would be my 30, this would be my 60, your hypotenuse is 2, across the side across from 30 is half that, and this is your root 3. But we're about to put these on a unit circle. So as a reminder, in a unit circle, your hypotenuse has to be 1. So what can we do to all of these ratios to make them 1? Well, in a 45, 45, 90 triangle, if I want this to be 1, I can keep this all in the same ratio by just dividing everything by root 2. So now that makes my radius 1. And when you rationalize, each of your sides of the 45, 45, 90 triangle are root 2 over 2. Same process with the 30, 60, 90 triangle. My radius has to be 1 on a unit circle. So I'm going to divide everything by 2. So those are your ratios on a 30, 60, 90 triangle. All right, so let's put this together. All right, here's my 45, 45, 90 triangle. And you know what, before I do that, I am going to do that. Hold on. What I want to discuss first are my quadrantal angles. So let's talk about what's happening on the axes. So the next part of this is to figure out what is the coordinate that goes along with each point at each of those angles on the unit circle. Well, since this is a unit circle, I don't need a triangle for what we call the quadrantal angles, which I know seems counterintuitive because you're like, I always tell kids, you always drive on a parkway and you park on a driveway. So this is one of those where we're going to talk about quadrantal angles that actually fall on an axis. So the point here is 1, 0. This is the point 0, negative 1. This is the point negative 1, 0. I'm sorry, that's a positive 1, positive 1, positive 1. I'm so sorry I made that mistake. Going a little ahead of myself. This is 0, positive 1. And then down here at 3 pi over 2, we have 0, negative 1. So friends, again, let's say that I want you to find the sine of pi. We know that sine is defined as y over r. I have to locate pi. Pi is located right here, but if you weren't sure, pi is 12 pi over 12ths, and I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to make sure I know where I'm at. And the y-coordinate there is 0. The radius is 1, so I know the sine of pi is 0. I just gave you that as just an example of where we're headed. If you're like, I didn't catch that, we're going to have plenty of opportunities for examples. But those are the coordinates of your quadrantal angles. Now let's talk about what the coordinates are for a 45, 45, 90 triangle. All right, so there's my triangle. It's 45, 45, 90. And we just learned from our previous slide that the sides are each root 2 over root 2, where the radius is 1. So in a 45, 45, 90 triangle at pi over 4, the coordinate there is root 2 over root 2. Now, if I take this triangle and I put it in quadrant 2, the values don't change. This is still root 2 over 2. This is still root 2 over 2. But what does change is the positive negative sign of your x-coordinate. So this is going to be negative root 2 over 2, root 2 over 2. If we would put that triangle in the third quadrant, it's going to fall here at 225 degrees. And in that quadrant, you have both x and y negative. And in the fourth quadrant, you're going to be over here, and that is going to be at 7 pi over 4, or 315 degrees. And you're going to have a positive x of root 2 over 2, but a negative root 2 over 2 is your y-coordinate. All right. I'm going to be erasing a lot of this because it is kind of a hot mess. But I did give you a link to an interactive unit circle. So if you pull up this GeoGebra applet, right now I'm showing all of your coordinates for pi over 2. What we just finished is pi over 4. And so at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. In terms of twelfths, that would be 3 pi over 4, 3 pi over 12, 9 pi over 12, 15 pi over 12, and 21 pi over 12. Those are the coordinates. So it's going to follow that if we put a 30, 60, 90 triangle on here, let me get the erase key. All right, let's erase all of that. All right, so if we put a 30, 60, 90 triangle up here, and it depends on what your reference angle is, so right here, I'm putting this at 30. And we recall that we needed a radius of 1, so this is 1/2. Reminder, this is 30 degrees, or pi over 6 radians, or pi over 6 in twelfths is at 2 pi over 12. This is my root 3 over 2. So the point at 30 degrees, or pi over 6, is an x value of root 3 over 2 and a y value of 1/2. To save a little bit of time, if we would rotate that triangle into the second quadrant, it is the exact same coordinates except your x is going to be negative. At 210, both the x and the y are going to be negative. And over here at 330, the x is positive and the y is negative. So again, if we look back on that other applet, all right, now there's the pi over 6 family. Let me turn off the pi over 4 family so it's clearer. So that's your 4 family of reference angles in those quadrants. And then again, last but not least, we're going to put the 60-degree triangle on there so you can visually see it. And if you are planning ahead, hopefully you can think, hey, it's going to be backward. All right, so if I put a 60-degree reference angle, I think I'm going to have to rotate this. Maybe I want to use this guy. I'm going to have to flip him, and I don't know how to flip him. All right, I'm just going to draw it in. All right, if we have a 60-degree angle, reference angle, all right, it's going to hit up here. All right, we have 60 degrees. This is your 1/2. This is your root 3 over 2 because we want 1 as my radius. So at 60 degrees, you're going to have the coordinate 1/2 root 3 over 2. So in the second quadrant, over here at 120 degrees, it is going to be the same values, but your x-coordinate will be negative. Your 60-degree triangle down in the third quadrant would be at 4 pi over 3, which would be at 240. And that is going to be a negative 1/2 and a negative root 3 over 2. And then over here, I missed. Over here at 300, we're going to have a positive 1/2, but a negative root 3 over 2. So this is your unit circle. Let me go ahead and take the pi over 6 down and show you the pi over 3. All right, and if we look at all of them together, that is what your unit circle looks like, and you can certainly, make that bigger or smaller so that you can see it. So your reality is that as you proceed into calculus, you're not going to have this unit circle in front of you. You're going to have to be able to do these problems without that in front of you. So please understand now that if you need this as a resource to start, use it. But I'm going to be showing you, or trying to exemplify for you, how do I put everything I've taught in this video together so that I can do the sine of pi over 6 without maybe that right in front of me. So here's what I remember. I remember that if you think about our values, 1/2 is the smallest. Root 2 over 2 is the middle value. Root 3 over 2 is the biggest. Why? Think about this. Compare your 2's. 1 is smaller than root 2, right? Because 1 is the square root of 1, root 2 is bigger than root 1, so root 2 has to be bigger than 1, and root 3 has to be bigger than root 2. So this is my small, this is my medium, this is my large. So let me just show you a quick example. Let's say that I want you to find the cosine of 5 pi over 6. All right, what I can do is if I don't know where 5 pi over 6 is quickly, I can convert to 12ths. So that's 10 pi over 12. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm right here. All right, if I draw my reference triangle in, I have a long x, that's root 3 over 2. I have a short y, which is 1/2. X is in a negative value, so I know that my point is negative root 3 over 2 1/2. Cosine is defined as y over r. Our r is always, I have a mistake. Let me go back. My cosine is defined as x over r. We know that your r is always 1. My x value is negative root 3 over 2. So the cosine of 5 pi over 6 is negative root 3 over 2. That is just one example of like how you should be able to do this quickly. I know that some of you might use a memorization technique. That's not wrong. You can memorize your values. I just don't know that you need to memorize them. You need to be able to get them quickly and efficiently. And some people just draw a triangle every time where like if they know it's a 45-degree reference angle, they do this and do SOHCAHTOA. None of those strategies are wrong. I'm just kind of showing you a unit circle approach. All right. So let's just recall. We know that's the sine, right, of an angle is equal to y over r, where r is 1, so it's just the y coordinate. We know that the cosine of an angle You know what? Let me change those to thetas so that doesn't make it confusing. Let's call these thetas. Your cosine of theta is equal to x over r. Your r is 1, so it's just the x coordinate. Your tangent is going to be y over x, and then our reciprocal values would just be those reciprocals. So if we're dealing with the unit circle where r is equal to 1, you can talk about all of your points on the unit circle in terms of their cosine sign, where sine is your y coordinate because it's y over 1, and cosine is your x coordinate where it's x over 1. So this is how we do these problems. I call these problems locate and state. You have to locate the angle, then you have to state the coordinate, and then you are able to evaluate that. So here we go. Remember, you always have your opportunity to, at any point, pause this or rewind this video. All right, the cosine of negative 4 pi over 3. And this is, I'm going to show you how I'm doing this without a unit circle in front of me. In terms of twelfths, 3 times 4 is 12, so 4 times 4, I have to go negative 16 pi over 12. All right, well, this gives me negative 12, 13, 14, 15, 16. So I'm up here. I have a short x, long y. So I have a short x and a long y. Cosine is the x value. This is negative 1/2 done. Tangent of 240. All right, degrees are generally pretty easier for students. 240 degrees, well, I know I have 180. So 240 degrees is going to put me down here. I have a short x, long y. I have a short x, I have a long y. They're both negative. Tangent is going to be the y coordinate over the x coordinates. Those cancel, so I get root 3. The sine of 7 pi over 4. Locate and state. Locate the angle. If you don't know where 7 pi over 4 is, convert it to twelfths. 4 times 3 is 12, so 7 times 3 is, so I've got 21 pi. Well, this gives me to 12 pi. This gives me to 18 pi, 19, 20, 21. Since that is the middle point, it's going to be the same. So that means that coordinate is going to be located at root 2 over 2, negative root 2 over 2. The sine is the y coordinate, so this exact value is negative root 2 over 2. Ooh, I did not mean to do that. Let's undo that. All right, let's talk about, let's see if I can copy, and then let's open this up and paste it. Awesome. All right, let's get some more room. All right, so cotangent of negative 3 pi over 4. Again, we locate and state. We locate the angle, we state the coordinate, we apply the definition. So I need to locate the angle. Well, if I don't know where negative 3 pi over 4 is, I can convert to twelfths. 4 times 3 is 12, so this is equivalent to negative 9 pi over 12. All right, so this is negative 12 pi over 12. And this is negative 6 pi over 12, so I'm going to be in the third quadrant. So negative 6, 7, 8, 9. All right, friends, you're at that middle point, right? So I have middle. So that means that coordinate is negative root 2 over 2, negative root 2 over 2. Negative root 2 over 2, excuse me. So my x coordinate and y coordinate are the same. So I know that tangent is defined as y over x. That means cotangent has to be x over y, and I can't go wrong in this problem, and I get 1 is the exact value. Cosine of 240. 240, this is 180 degrees. 240 is going to be down here, so that's my locate. Short x, long y. Short x, long y. Cosine is the x value, so I have negative 1/2. All right, and last but not least, let me do some erasing so I give myself some room. We have 11 pi over 6. Locate the angle, state the coordinate, apply the definition. So in terms of twelfths, 11 pi over 6 is going to be what I have to multiply by 2 is 22 pi over 12. Now you can count in a positive direction, but one full revolution is 24 pi over 12. So let's just go ahead and back up 2 units. So that's going to be a long x short y. Long x short y in a negative direction. Okay, I know that secant is the reciprocal of cosine. Cosine is the x-coordinate, so I have to flip the x-coordinates. And when I rationalize, the secant of 11 pi over 6, its exact value, is 2 root 3 over 3. As a reminder, when I say exact value, this implies no decimals. So if you were using your calculator, you should not be using any technology to do this. Please know that this skill is necessary and critical for your success in the rest of this course and in calculus. So if you don't like my way of getting exact values, again, if you use a memorize, some students use triangles. I just wanted to show you a unit circle approach, but you need to be successful. All right, let's look at problem 15. State what quadrant in which theta lies. Okay. So the secant of theta is greater than 0. This implies it's positive. We know that secant is the reciprocal of cosine. Cosine is the x-coordinate. Where is x positive? It's positive in the first and the fourth quadrants. Cotangent, however, is less than 0. This means cotangent is negative. Cotangent is the reciprocal of tangent. Tangent is y over x, so cotangent is x over y. In order to be negative, one of either the x or the y has to be negative. Well, in the first quadrant, everything is positive. And in the third quadrant, x and y are both positive, giving it a cotangent of positive value. So cotangent is negative in the second and the fourth quadrants. Where do they overlap? Quadrant 4, so quadrant 4 is a final answer. And our last example, find the values of the 6 trigonometric functions of theta with the given constraint. Okay, the cosecant of theta is equal to 4. So let's do our little chart. Okay, we know that the cosecant of theta is equal to 4. We know we need to find out the cosine. We need to find out the tangent. And we've got secant, and we've got cotangent. Well, we know the sine is 1/4, right? Because those are reciprocals. That means sine's positive. So that means this angle has to live in either the first or the fourth quadrant. But because, and you know what? Back up. Mistake. I had the last problem on my brain. I am so sorry. Actually, you know what I probably did? I did what a lot of kids do. I looked at cotangent, and I guarantee you I was thinking cosine in my brain. So I think I've mentioned this in other videos before. Don't do what I just did. So let's read. Let's back this truck up. Cotangent, right, is negative. Cosecant is positive. Sine and cosecant are positive in the first and the second quadrants. When we want to look at where the cotangent is negative in the second and the fourth quadrants. So that means this is a second quadrant angle. So why is this important? All right, this is important because I'm going to draw my triangle. And this is not a unit circle problem. If I look at this, this is going to be y over r. So my y-coordinate is 1. My radius is 4. I'm going to do Pythagorean theorem. 1 squared plus x squared equals 4 squared. So x squared is equal to 15. So this is a negative root 15. So your cosine is going to be negative root 15 over 4, which makes your secant negative 4 over root 15. And when you rationalize, I get negative 4 root 15 over 15. Tangent is going to be 1 over negative root 15, which gives me a negative root 15 for the cotangent. That satisfies that. And when you rationalize your tangent, you get negative root 15 over 15. My apologies if I have said something. This is my last example. I've been talking for a while, so if I did make a mistake in that last problem, holler. But you are ready to go to your Unit 1, Lesson 1, Part 3 web assign. Enjoy.